Assalamualaikum and good day, dear students. Today we are going to continue with our discussion for chapter 1 on innovative vapor compression refrigeration system. In our previous discussion, we have looked into ideal and actual case of vapor compression refrigeration cycle. We found that it is simple, inexpensive, reliable, and practically it is maintenance free. However, for some applications, such as large applications where the simplicity is not a major concern, the simple vapor compression refrigeration cycle, as discussed previously, is found inadequate and modification need to be done. There are 5 innovative vapor compression refrigeration cycle that we'll discuss in this section. They are Cascade Refrigeration System, Multi-Stage Compression Refrigeration System, Multi-Purpose Refrigeration System, Liquefaction of Gases, and Absorption Refrigeration System. Now let's have a look at Cascade Refrigeration System. Cascade Refrigeration System is used for industrial applications that requires moderately low temperature that cannot be achieved by the simple vapor compression refrigeration cycle. Due to large temperature and pressure range or difference between condenser and evaporator to reach the low temperature requirements, larger compressor may be needed to accommodate this situation if simple vapor compression refrigeration cycle is used. This may imply to the cost and the practicality of the system. Thus, one of the solutions is perform the refrigeration process in stages or in cascading manners. Normally, cascade refrigeration system operated between 2 to 4 stages. The schematic diagram shows the devices and how it link. For the TS diagram, the phase of each states are shown in detail. If we are using the simple vapor compression refrigeration cycle, there will be one compressor, one condenser, one expansion valve, and one evaporator. However, when cascade refrigeration system is applied, it will have more than one for each devices. For example, for two-stage cascade refrigeration system, as shown in the schematic diagram, there are 2 cycles where each cycles are having their own compressor, condenser, expansion valve, and evaporator. Note that different stages are having different piping system. Therefore, cascade refrigeration system can use different types of refrigerant since there is no mixing between the stages or cycles. Also, note that evaporator for cycle A and condenser for cycle B is combined to become a heat exchanger. The heat from cycle B will be rejected to cycle A, or in other words, the heat from cycle B will be absorbed by cycle A. Other processes in this two-stage cascade refrigeration system is similar with the simple vapor compression cycle. Now, if we plot these processes to the TS diagram, it can be presented by this. These are the processes for two-stage cascade refrigeration system. And these are if we use a simple vapor compression cycle. As we can see, This area under the graph is the decrement towards the work consumed by the compressor. And this area under the graph shows an increment to the refrigeration capacity that will be used to absorb the heat from our conditioned space. Instead of this much of heat that is being absorbed, it now can absorb this much. We can summarize that Cascade Refrigeration System decrease the compressor work, increase the amount of heat absorbed, and thus increase the coefficient of performance, COP.